Hello, Assalamu alaikum, Bismillahir Rahmanir Rahim. I am Mudassir Mehboob, lecturer in chemistry GPGC Sawabi, and bring you another very exciting episode on UV visible spectroscopy. In this lecture, we will cover the introduction of the UV visible spectroscopy, the principle of a UV visible spectroscopy, its instrumentation, the mechanism of interaction, that how UV visible light interacts with the matter, and interpretation of a UV visible spectra. Stay with me for just 5 minutes, and you will be able to know all these things regarding UV visible spectroscopy. Okay, so what is UV visible spectroscopy? In UV visible spectroscopy, UV visible light is used to interact with an organic or inorganic species. Okay, and after their interaction, we can get a spectra, and that spectra give us the clue that a particular analyte, a particular substance, a particular sample is what, okay, and in which concentration. So actually, UV visible spectroscopy is a modern spectroscopic technique which is used for the qualitative as well as quantitative analysis of a sample, or we can say an analyte or an organic or inorganic molecule. What is the principle of UV visible spectroscopy? So UV visible spectroscopy is based on the absorption. Okay, in UV visible spectroscopy, when UV visible light falls on the sample, so that sample absorb some of the radiation, and the rest that is transmitted. So that transmitted light is actually detected by the detector and give us a spectra, and in that spectra it is elaborated that which light, what wavelength of a light is absorbed, and in which concentration that light is absorbed. So that is what the principle of the UV visible spectroscopy. Now come to the instrumentation. In instrumentation, we use simple UV visible source of light. Okay, then we need a monochromator. A monochromator is used for a purpose to get a single wavelength of UV visible light, because the UV visible light range, is from 200 nanometer to 800 nanometer. Okay, from 200 to 400, that is the UV light, and the visible light, that is from 400 nanometer to 800 nanometer. So this is the whole range of so monochromator is used to actually just split that polychromatic light to monochromatic light, a light of a single wavelength. Okay, then that monochromatic light is passed through the sample will absorb some of the light, and the rest that is emitted, that is transmitted, and the detector actually detect that, and after detection it will give signal to the screen, and screen will give us a spectra, actually absorption versus wavelength as a spectra, and that spectra we can interpret, and from that we can determine that what kind of sample is used. Okay, so how UV visible light interacts with the organic molecule or any other species. So when UV visible light falls on an organic molecule or any other molecule, so that molecule have valence electron, and they are present in their own you can say energy level. Some of the energy levels are sigma level, some are the pi level, some electrons are present in the n level. So these electrons are actually excited by that UV visible light which falls on it, and due to that electronic excitation, some of the energy, some of the UV visible light is absorbed, and that is detected by the detector and give us the spectra. And that spectra is actually then illustrate that what the molecule is actually. Due to this reason, UV visible spectroscopy can also be called electronic spectroscopy, because electronic spectroscopy. Why electronic spectroscopy? Electronic spectroscopy mean electronic excitations occur, इसमें इलेक्ट्रॉनिक एक्साइटेशंस अकर होते हैं. दैट इज़ द रीज़न दे बीन कॉल्ड इलेक्ट्रॉनिक स्पेक्ट्रोस्कोपी. Okay, and now the interpretation. So the spectra जो हमारे पास आता है, वो इस फॉर्म में होता है. लुक एट, वो इस फॉर्म में होता है. जस्ट लुक एंड सी. हमारे पास ये वाई एक्सिस पर, और ये जो है ना आप लोगों के एक्स एक्सिस पर, यहाँ पर हमारे पास वेवलेंथ होता है. वेवलेंथ and that is in nanometers, and that is absorption. यहाँ पर absorption होती है और यहाँ पर wavelength. So एक्चुअली हमारे पास इस किस्म का स्पेक्ट्रा बन जाता है. यहाँ पर take two things in the consideration. Okay, that what wavelength of light is absorbed. First one, what wavelength? What wavelength of light is absorbed? Absorbed. More means more, so that is lambda max. So the wavelength at which maximum absorption occur. So maximum absorption देखिए, that is the absorption. So maximum absorption is occur at this wavelength. If it is paracetamol, so then it will be 249 nanometer, because the lambda max for the paracetamol is 249 nanometers. So from this we can now the concentration of the concentration of the paracetamol can be determined from this, that absorption, how much absorption occur. So that is okay. If we will get this kind of spectrum, okay, that is. So here this is the lambda max 249, वही 249 पर आएगा. अगर कंसंट्रेशन पैरासीटामोल की कम हो तो ये, अगर पैरासीटामोल की ज़्यादा हो तो ये, वेवलेंथ पर कोई फर्क नहीं पड़ेगा. तो keep in mind the two things. One, at which wavelength maximum absorption occur, and how much absorption occur at that wavelength. How much absorption occur. So how much absorption, that is from that will give us the concentration, that is the quantity, that is the quantitative analysis. and at which wavelength, that will give us the qualitative analysis. Thank you very much. Thank you very much for watching, and give me your feedback. I will give more and more video on it. Okay, and my next video will be on IR, NMR, and mass. Okay, thank you very much. Thank you very much.